Example question 33. A car moving in the x direction has an acceleration ax that varies with time as shown in the figure. At the moment t is equal to 0 seconds, the car is located at x equals 12 meter and has a velocity of 6 meter per second in the positive x direction. What is the velocity of the car at t equals 5 seconds? So in the first part of the question, they are just asking you what is the velocity of the car at t equals 5 seconds. Here at t equals 0 seconds, my velocity is 6 meter per second. So I can write my initial velocity v0 to be 6 meter per second. Since I have been given acceleration versus time graph and I need to find velocity from it, I'm going to take the area under the graph to find this velocity. So we write velocity v to be equal to area under the graph plus the initial velocity v0. So since we need to find velocity until 5 seconds, we are going to take the area under the entire region of the graph. And since this region is a triangle, when I take the area, I have to take the area of the triangle. So we write v equals half times base times height, which is the area of the triangle, plus v0. So here in this figure, base is the time axis. So we are going from 0 to 5 seconds on the time axis. So my base is 5, whereas height is on the acceleration axis. You're going from 0 to 4, so your height is 4. Substitute this, you get v equals half times 5 times 4 plus v0 is the velocity at time t equals 0 seconds, which is 6. When you solve this, you get the velocity at time t equals 5 seconds to be equal to 16 meter per second. In part B of the question, they want me to draw a corresponding velocity time graph for between time t equals 0 to t equals 5 seconds. If I want to draw velocity versus time graph, I need to know the velocity function v. And if I need to know velocity function v, I need to know what is the acceleration function a. Because if I know what is acceleration a, I can integrate the acceleration value to find the velocity function v. And we can determine this acceleration function from the graph given to us. We have acceleration versus time graph. And this graph is a straight line. So I can use the equation of straight line to find the equation or the function of acceleration a. So we know that equation of straight line is y equals mx plus c, where y is the value on the y-axis. On the y-axis, I have acceleration a, so I will write it as a here. M is the slope of the graph, so let us first calculate the slope for me to substitute for m. So we write the slope as m, which is equal to slope, that is equal to y2 minus y1 over x2 minus x1. So I'm going to select two values on my graph to take as x1, y1 and x2, y2. Let's start from the initial point over here. I will call this point x1, y1, which is 0, 4, x1, y1. And the final point here, I will call this x2, y2, which is 5, 0. This is x2, y2. Substitute this in the value for slope. y2 is 0, y1 is 4, over x2 is 5, x1 is 0. When you solve this, you get your slope as negative 0.8. I'm going to substitute this value in place of m in my equation of straight line. So we write this as a equals negative 0.8. X is the value on the x-axis, and on x-axis we have time here, so I will write time t, plus c is the y-intercept. Y-intercept means where does my line crosses on the y-axis. So on the y-axis, my line is crossing at acceleration value equals 4 meter per second squared. So I write this y-intercept to be equal to 4. This is my acceleration function A. I'm going to integrate this acceleration function to get the velocity function. So let's find velocity function v. V will be equal to integral a dt. That will be integral of negative 0.8 t plus 4 dt. So the first step in integration is to identify the power of t. Power of t in the first term is 1. In the terms where there is no t, where you have a constant like this one here, power of t you take as 0. After you identify the power of t, now increase the power of t in each term by 1. So this will become negative 0.8, increase the power of t by 1, t to the power 2, plus 4, increase the power of t by 1, t to the power 1. After you increase the power of t by 1, now divide by the new power. So divide this by 2, and dividing this by 1 will give me the same number. Then you have to add a constant v0. V0 is the constant which is the initial value of velocity. Now we solve for this. We can simplify this. Negative 0.8 by 2 will give me negative 0.4 t squared plus 4t. And v0, which is the initial value of velocity, here is 6 meter per second. This is initial velocity when time t is equal to 0. So in place of v0, I will write 6. So this is my velocity function v. Once I found the velocity function, now I can use this function to plot my graph. So we have the time value going from time t equals 0 to t equals 5 seconds. I'm going to use this time value and substitute in my velocity function to get the corresponding velocity value. So we will take time t equals 0, 1, 2, 3, and so on, and substitute them one by one in the velocity function to find the corresponding velocity values, like the one shown in this table here. First, I substitute my time t as 0 in the velocity function. When you do that, you get the value of velocity to be equal to 6. Then you substitute time t as 1 in the function, and after solving, you get velocity as 9.6. Then you do the same thing with time t equals 2. Substitute that here, t equals 2. And after solving, you get velocity as 12.4. Do this until time t equals 5 seconds and find the corresponding velocity value. Then we are going to plot a graph with velocity on the y-axis and time t on the x-axis. So when you plot a graph, this is the relationship that you get. When you're plotting the graph, make sure you label the axis time t with seconds, velocity with meter per second, and you write the title of the graph. Then when you are putting the values on the axis, make sure that the intervals are same. The difference between any two consecutive values remain the same. Like 5 minus 4 is 1, 3 minus 2 is 1, and 2 minus 1 is 1. The interval must be the same. Same thing on the y-axis. Do not directly put the values on the table on your graph. Make sure your intervals are the same. So when you plot your graph, you get a curve with velocity values increasing with time. So this is the kind of graph you get from the velocity function that we found. So this completes part B of the question. In part C of the question, you need to determine the total displacement at t equals 5 seconds. Now when we plot velocity versus time graph in part B, we got our graph to be a curve. If it were a linear graph, I would just take area under the graph to find displacement delta x. If it's not a linear graph, I'm going to again use my velocity function to find the displacement. So we are going to integrate the velocity value to find the displacement x. I write x equals integral v dt, which will be integral of the velocity function negative 0.4 t squared plus 4.0 t plus 6 dt. Now we follow the steps to integration. First, we identify the power of t in each term. Here the power of t is 2. Here it is 1. The last term is a constant, so we write power of t with the constant to be t to the power 0. After you identify the power, now increase the power of t in each term by 1. So negative 0.4 t to the power 2 will become t to the power 3 plus 4.0 t to the power 1 will become t to the power 2 plus 6.0 t to the power 0 will become t to the power 1. After you increase the power of t in each term, now divide each term by the new power. So divide this by 3, divide this by 2, and divide this by 1 plus the constant x0. Now, since I want to find the displacement delta x is x minus x0. So I will move this x0 to the other side to find my displacement. X minus x0 will be equal to negative 0.4 t cubed by 3. 4 divided by 2 will give me just 2 t squared plus 6t. This is my displacement function. I want to find displacement at time t equals 5 seconds. So in place of t here, I will substitute 5. You get negative 0.4 by 3, 5 cube plus 2, 5 squared plus 6 times 5. And that gives me my displacement delta x to be equal to 63.3 meter.